Okay, so we're going to start solving rational expressions and rational proportions. And so again, let me just give you a quick reminder about what a proportion is. We haven't seen this word in a while. So proportion is really just a fraction equals a fraction. We're comparing two fractions. We're claiming that they are equal to each other. So a simple example of this would be something like 2/4 is equal to 3/6. Right? So if I take a look at these are both true because 2/4 and 3/6, if we were to simplify them, both equal 1/2. Okay, but we have a way of verifying, okay, or a rule about proportions that is true, and we can use it to verify that a proportion is actually a true statement. And we have what's called cross multiplication to do this. A property of proportions that always works is that if you multiply the numerator of one of the fractions times the denominator of the other, in this case 2 times 6, that should always be equal to the other, okay, multiplication of the other diagonal. So 4 times 3. Okay? And if you notice, this works. 2 times 6 is 12. 4 times 3 is also 12. So this is a method that when two fractions are true, are equal, that this will be true. So we can use that to our advantage for our algebra problem here. Okay? Our algebra problem says that 4/x plus 2 should be equal to 3/x plus 1. So what we know is that if we were to cross multiply and do 4 times x plus 1, which I'm just going to write as 4 times x plus 1, that should be the same as 3 times x plus 2. For the same reason that 4 times 3 and 6 times 2 are equal. We're just applying a property of proportions. Okay, so to solve this, it's pretty straightforward now. Okay, I can just distribute 4x plus 4, okay, is equal to 3x plus 6. Okay, and then we can do our what we know about solving algebra problems. Subtract the 3x over, and I get x. Subtract the 4 over, and I get a 2. Okay, so my answer here is that x is equal to 2. So let's just check and make sure that actually makes sense. I'm going to go back up to my original problem, and I'm going to plug in a 2. This says 4 over 2 plus 2. Well, 2 plus 2 is 4. Okay, and the other side says 3 over, well, when I plug in a 2 here, I get 2 plus 1, which is 3. And if you take a look, 4 over 4 is 1. 3 over 3 is 1. So this checks out, right? Our answer, 2, made the proportion a true statement. Okay, and so that's what we're trying to get at. However, when and this seems pretty straightforward, but there's special cases that we need to watch out for. So here is one of our special cases. We have this concept called an extraneous solution. An extraneous solution is a value that appears to be a solution, meaning that we went through the problem, we did all of our algebra correct, we got down to the answers. Okay, however, when we plug those answers back into the original equation, it doesn't work, right? So it makes the original equation not true, right? And so it's something that we have to be careful about because all of our work will be correct. We'll get down to the answer at the end, but if we don't check, it's possible that we'll be giving people some answers that don't actually make the equation true. When we go back up to this problem, when I plugged in 2, I went back to the original equation and it gave me a true statement. Okay, so let's check out a problem where maybe that doesn't work, right? So you have to check your answers. So let's do this problem just like we did the last one, and we're going to see if the answers that we get actually work when we plug them back in. So I'm going to cross multiply just like I did before. I have fraction equals fraction. So I'm going to say 6 times x plus 5. Well, that would be 6 times x plus 5, okay? And then the other side would be multiplying together the two binomials, which would be x plus 3 times x plus 5. Okay, so I have to distribute on both sides. So the left-hand side is x plus 30. Okay, and the right-hand side is just a FOIL, so we just get x squared. Okay, we get a 5x and a 3x. That's 8x. Okay, and we get 3 times 5, which is 15. Okay, so now I see a quadratic happening here, so I got to set this equal to 0. I'm going to subtract these two left-hand elements over to the right. So it's going to say 0 equals x squared. When I do 8x minus 6x, I get a 2x. Okay, and when I do 15 minus 30, I get negative 15. Okay, so to solve this, we know that we factor. So this is going to factor into x plus 5 and x minus 3. Okay, equals 0. And then we can set each of these factors equal to 0 and get our answers. So the one possibility is that x plus 5 equals 0. And the other possibility is that x minus 3 equals 0. So my first one, factor yields an answer of negative 5. and my second factor yields an answer of positive 3. So it looks like we did everything correct, and you can go back and double check your algebra. We didn't make any mistakes, and I have 2 answers, right? So if we stopped right here and said, here are your solutions, -5 works and 3 works, okay? We need to go back and check if this actually makes the original statement true. So let's check 3 first, okay? Because 3 is actually the solution that's going to work. If I plug that in, I get 6 over 3 plus 5, 6 over 8, okay? And if I plug in 3 here as well, it looks like I get 3 plus 3 is 6 over 3 plus 5, which is 8. So that one checked out. When I plugged in 3, I get 6/8 equals 6/8. So we'll call this the case when x is equal to 3. Okay, I do get a true statement. Okay, so let's check the other one. When x is equal to -5, let's see what happens. I get 6 over, when I plug in a -5 here, I get -5 plus 5. Oh no, I got a 0. And the same thing happens on the right. I'm actually going to get -5 plus 3. Okay, well, -5 plus 3 is -2 over, I got a 0 again. Okay, so this is actually not true because this doesn't yield any answer at all. When I try to do 6 divided by 0, it doesn't exist. That is not an answer. So in this case, this extraneous solution, okay, x equals -5, it appeared to be an answer, but it gave us, when we plugged it back in, it gave us a statement that was not true. Okay? In this case, the reason, because we're actually saying one of our answers is an undefined value. I can't use -5 in here because that makes 0 show up in the denominator. Okay? So we have to be careful that we check our answer for these extraneous solutions to make sure that when I plug them back in, I actually get a true statement.